Hello everyone, Dr. Suresh here, and in this video we'll talk mainly about the major differences between aerobic glycolysis and anaerobic glycolysis. So in our previous videos we have discussed that the glycolysis, how sequentially changing into the end product, that is pyruvate, okay, and the fate of pyruvate decided by the availability of the oxygen. Okay, so here first we'll discuss about the anaerobic glycolysis. What is anaerobic glycolysis? So if the glycolysis keep on continuing, okay, in absence of oxygen, that is known as anaerobic glycolysis. Okay, here we are aware there is a production of NADH2 at one of the steps in the second phase of glycolysis by the enzyme glyceroldehyde 3-phosphate dehydrogenase. Okay, so anaerobic glycolysis, what is happening? Majorly the reoxidation of NADH which is produced at that level will be reused by the pyruvate to convert into lactate. Okay, and with the help of the enzyme Lactate Dehydrogenase. Okay, here pyruvate is converting into lactate. The difference between pyruvate and lactate is 2 hydrogens. Okay, this is an acid, this is a keto acid. Okay, the lactic acid and then pyruvate, the only difference is 2 hydrogens which will be donated by the NADH. Okay, NADH2, actually 2 pyruvates are there at the end and 2 lactates. Here also 2 NADH2 will be converted into 2 NAD. That means 2 hydrogen has been donated to pyruvate to form lactate. And we are all aware what is the source of this NADH2? That is glyceroldehyde 3-phosphate dehydrogenase, okay, which produces 2 NADH2. Okay, so this is coming from here to here. Right. So the tissues which are that functioning under hypoxic conditions, that means if there is a non-availability of oxygen, so they will be readily producing lactate. Suppose if you are trekking in higher altitude, there is a low level of oxygen. So what happens? So most of the cells start producing lactate. Okay, if you are hitting a gym, okay, after a long, if you are doing a strenuous exercise, there also there is a shortening of breathing. Okay, and then what happened? There is no availability of oxygen at the skeletal muscle. So there also this pyruvate will be producing lactate. So where and all it will produce skeletal muscles and smooth muscles and erythrocytes, there is a chance of production of lactate in non-available conditions like absence of oxygen. So you see here in this pathway flowchart, you see glucose up to pyruvate is a similar one. Okay, so this glyceroldehyde 3-phosphate, note down it, and here it will be converting to 1,3-bis-phosphoglycerate and the end product pyruvate and pyruvate to lactate. And remember here in anaerobic glycolysis, conversion of pyruvate to lactate is reversible. Okay, and the enzyme for conversion of pyruvate to lactate, the enzyme is lactate dehydrogenase. Same way, conversion of lactate back to pyruvate, again the same enzyme lactate dehydrogenase. You see here in the energy gaining phase where NADH2 is produced, will be reutilized here. Okay, and what happened? That NADH is converted into NAD, and again this NAD will be going back and again reutilized in glycolysis. Okay. So that are the sequential reactions of anaerobic glycolysis. Okay, so what is the amount of ATPs will be produced in case of anaerobic glycolysis? In case of anaerobic glycolysis, what happened? We have invested 2 ATPs. We invested 2 ATPs in the beginning of the first phase of the glycolysis, and later on we have got 4 ATPs, and next 2 NADH2. Okay, 1 NADH2 gives rise 6 ATPs, and we have already got, because of the substrate level phosphorylation, 4 ATPs. So that means total 10 ATPs we are getting, and we have invested 2 ATPs in the beginning. Okay, so 10 minus 2, you will be getting total 8 ATPs. But here we are talking about anaerobic glycolysis. Again, what is happening? The NADH which is produced here, again reutilized. So it will not be entering into electron transport chain. So we are not supposed to take count of NADH, that means 6 ATPs. Okay, so 6 ATPs we are not taking. So only 4 ATPs. So how many we have invested? 2. So total 4 ATPs minus 2. So net you will be having 2 ATPs. Okay, So in anaerobic glycolysis, the total number of ATPs that we are going to get only 2 ATPs. Total will be 4, and we have to minus the earlier invested ATPs. So 4 minus 2, and the net production of ATPs will be 2. So remember, the net production of ATPs in anaerobic glycolysis only 2 ATPs. Thanks for watching. Thank you.